2D to 3D redimensionalization. And a lot of people are like, well, that's a lot of syllables. But basically what we're talking about here is the process of taking shot footage that was shot in standard single lens cameras, and how do we take that and pull it out into a stereoscopic shot? How do we make it 3D so the 3D glasses will work for it? Not everyone has the budgets to be running around with 3D cameras. Not everyone was thinking of shooting 3D, and then someone else later on goes, actually, I know you're finished shooting, but we decided we're going to put this in a theater where we're going to show it as a commercial before a stereoscopic movie, so now you need to make it stereoscopic. So that kind of stuff happens, and it's happening more and more. So we have Will over here, who's running on our Flare system, who's going to take you through the process of doing exactly that using Flare. So Will, take it away.
Thanks, Sean. So yeah, we're going to be taking a look. And by the way, guys, if you wouldn't mind handing out some Anaglyph glasses at this point. I think some of our guys over there will give you some stereo Anaglyph glasses. We're going to be taking a look through the Flame Premium family, specifically at Flare, with a little bit of Maya. And the task before us is the business of extracting 3D information from a monoscopic source and essentially building the structure of a shot and then sweetening or tweaking or optimizing that stereo effect. So it's quite a big subject. We're just going to spend half an hour here going through a couple of examples. But working here on the Flare system, you're going to see uses of the displacement technique, the rotoscoping and tracking techniques, as well as projection right in the system here. So kind of a small, medium, and large example I'm going to take you through. The scenarios, as Sean was just saying, where you might want to do this would be typically with perhaps a commercial or trailer type job that gets the opportunity to work on the head of a 3D movie, a 3D stereo movie. It could be a short form piece, could be a long form piece. I'm actually just going to start by playing this back to give you a little visual idea of the kind of challenges that you might be approached with. It's a kind of a funny commercial from the guys at Digital Pictures. This one's not in stereo. We're going to make some shots stereo as we go. But visual effects shots often tend to be the easier shots to convert because you're going to have mattes, you're going to have depth, you're going to have drift and perspective and parallax as part of your composite. But live action material with organic creatures, with different depth cues or things in the shot that would naturally draw out into stereoscopic placement are much more challenging. So hence the way we're not actually going to do that much compositing here. We're going to do rotoscoping, depth adjustments, displacement, and so on. So kind of a funny piece there, thanks to the guys from Digital Pictures. Let's just take a look at a couple of examples. Specifically, I just mentioned that visual effects shots tend to be easier. And what I mean by that, here's just essentially the render, if you like, of a particular shot here that uses stills of mountains and spreads them out in space for a monoscopic result. It's awesome. But if you actually look at the pieces that built this, because we're in the Flare environment here, which is actually using the Flames batch environment, we have access to the setup. We have access to all the tools that made this. Specifically here, I'm going to take this node, I'm going to expand it out entirely. And what I mean by that is I'm going to take out the live comp. Instead of looking at a dumb render, if you like, I can get back to the pieces that made this in the original job. And you'll see if I show you a kind of an orbital view here, that this is really laid out in space for a monoscopic work. This really lends itself well to being turned into stereo in case I can, in fact, I can simply just take the camera and go turn it stereo. So now you are seeing a stereo result. And because of the layout of this scene, what we just saw here with the working view, you can see why this works. It's because essentially it has the ability to be then manipulated. You can really get the idea. If I just adjust my camera like this a little bit, you can see how I can just scan past the different parts of the scene, move up and down and around. I can even go change the stereo attributes. This is our FBX camera, which is common to Maya. So all the way in your compositing and finishing process, you can get access to these live stereo cameras if you'd like. So visual effects work can lend itself well. What tends to be even much harder could be stuff like this, where you have no visual effects. It's just drama material, and you need to deal with things like organic objects, moving things that are not sort of simple cubes or things that you can just kind of just pick static shapes for. So there's a few techniques that I would use to break this apart. You've probably heard of the technique of using cards, or ways of basically defining different regions of the image and pulling them back and forth in depth. That's exactly what we're going to do. We'll take a couple of layers here. I'm going to break this into a few cards for you. And let's just start by looking at the hand. So these are just flat images at this point. But what I'm going to do is I'm just going to show you some of the tracking and rotoscoping tools that we have for this inevitable process, made a lot less painful, I think, than you might imagine. So I'm just going to pull out a mask, and I can literally start drawing on this layer. So let's just go ahead and draw around this hand. And you might have been thinking, well, there's a lot of hand roto to do there, especially with this guy. I think you'd be surprised at how quickly things can be dealt with. So I'll just draw a mask here, and then I'm going to just start the process by tracking this through. So we'll go to the end frame here, and what we'll do is we'll send this back and forth. Actually, I'll start there. And as we take our tracked, essentially our drawn out mask, I'm going to shape track it backwards. In this case, as I'm at the end of the shot, and what you'll notice is that it follows that all-important natural movement. Now, even if the edges don't quite work, if I can get some kind of movement track, I can easily kind of hand keyframe the changes from the beginning to the end, maybe add one in the middle if I'd like, to get the basic thing working. So you can just see how this all-important natural movement is grabbed. Then I can take my pieces here, move them about. If I wanted to, I could even come in here and deal with the scale of a certain part of the object to naturally grow and shrink these pieces. So if we just take that and make it a selective mask, so it's just essentially biting into this layer, what we'll do here, we just draw that link. Okay, so what I'm doing is I'm coming in here and I'm isolating a particular layer. I'll actually take that mask and invert it here. And as I start moving my layer here, what you'll start to notice is that it really is moving in 3D space, and the stereo aspect here is changing. But I don't necessarily want to change its scale. What I want to do is something more like this, using what we call our auto scale function. I'm going to naturally move it in space. Here's the camera frustum, but I'm going to move it so that it keeps the same size, but changes its stereo attributes by moving back and forth in front of the camera. So essentially, if I decide, hey, I want the hand about there, that's great. The next step would be to take something like this still that we made, which is a displacement source. So essentially, I've just painted up the tones of the face as white and black as a still, and I wanted to track this in on the face layer. So literally, the technique here is just to go ahead and take this guy, and I'll use a different kind of tracking now. This is just to be a 2-point track that allows us to say, okay, I want to grab points on the image now and do an analysis of this. So as we just analyze through the shot here, you see this is a different way of grabbing data, but it's a great optimization, right? You don't need maybe a hand-animated displacement here. You just take something like this, and I'm just sort of lining it up at this point into place. So just so you can see the building blocks here of how you would take these guys, and then let's just zero him into just the right spot here, so that as we move through the shot, we're going to get a displacement that's meaningful for our guy. Now, I don't want to use that as an image. Instead, what I want to do is take that track data and use it as what we call a displacement map. So this is just a way of taking the pixels, if you like, if you think of your video as a mesh. Effectively, what you can do here is you can say, hey, I want to distort them in space based on this color value data. So what I'm going to do is take my displacement, and let me just show you it from the side view again. This is the layer that we're interested in right here. It's this one up here. And as I move things in Z, you're going to be able to see how things move back and forth. Now, he's doing an adjustment in flat displacement, which means he's coming straight out. What we really want is camera-based displacement. So this is essentially the same kind of technique as that auto scaling, where he changes aspect as he comes closer to the camera. And you can see clearly here how I can decide how soft I want that to be. I can also look in a wireframe view here if I'd like to just get an idea as to how what's really happening. So that flat piece of video as a mesh is now being distorted via this information, right? So you can get the idea that this is a combination of card and displacement techniques. If I go a little bit further with this, you could see how by dividing into a few more cards, so a little bit further along here, I can get a result that gets to be really quite interesting really quickly. So there's a kind of I feel like a finished article using about 5 or 6 different cards in the shot. Hopefully you can really see how the guy's chin stands out from the collar, his hand is lifted in front. And if we look across at our working view here, one more time, you can really see why this works. It's because it really is laid out in space. It's laid out so that we can easily define, okay, we want the hand to be in that position. We want this to be in each position. We can just tweak it back and forth as we see fit. So one last thing here would be the pixel spread node, which is a great little technique for dealing with parallax artifacts. One of the problems that you're going to run into when you start extracting things in 3D space is that by pulling something and shifting it in both directions, left eye left, right eye right, that will push the object forward. But as your eye looks around, you're going to see an artifact of the baked foreground object in the background, right? There's no mats here. There's no isolated clean plate yet. And whilst some shots will demand that, this pixel spread technique is a great way of reducing enough pixels without having to do manual paint to actually be able to deal with the overall effect. So if we take a look at the result here, I'm just going to show you, the effect of this. I'm actually just going to view in the context of our result here, and if I just turn this off, you can see the edge on the hand, right? So if you look with your glasses, you'll be able to see the edge. If I bring my pixel spread back into line here, now you'll be able to see the effect of being able to, instead of having to paint out a clean plate, we can just suck the pixels in to get a great result in that kind of case. So let's take a look at another interesting shot here that's maybe just gives you an idea of the variation of things that you might run into. If you had a shot like this, which was just a large flying through shot coming through a valley here and seeing essentially this whole environment, there's a lot of depth in there, right? There's a lot of cues for depth. There's trees in front of grass. There's the whole thing. This is where I might enlist a little bit of the help of a 3D artist to build me some geometries beyond the basic primitives that I can do in here that represent the scene. But he would need something to work with, so I'm actually going to use what we call our analyzer node to build a camera analysis. In this case, it's mono source footage. We also have a stereo analyzer here in our node bin. But what I'm going to do is I'm just going to trigger an analysis here so that you can see the process of solving the camera. It's like a match move track or essentially a 3D camera solve that also builds a point cloud along the way. This is a pretty automated process. Some shots, if you have objects in the foreground that you want to miss, you would draw mats. But here what I've actually got is a point cloud being generated here that represents the scene in 3D space. So if I just take a look from that orbital view that we've been looking at before, let's take a look at this one, you'll be able to see what I mean. So now I've got a camera that actually flies through the scene. It's moving and the objects are assumed to be static, which makes sense, right? So this is just a great way of being able to solve your camera move and build something that would be useful to your 3D artist to actually put ground in. Put in the trees in the foreground here. If I zoom back a little bit more, you'll be able to get a better idea that this really does represent the physical layout of this scene with the camera flying through and so on. So this is a great foundation for your scene if you have this kind of move. I'll actually just take another step here to actually define a plane. So I'm going to say instead of starting from a notional ground, I want to actually tell my my 3D guy a little bit more about this scene. I want to be able to pick points and pick essentially a ground. If we come back over here, you can really see now how now I've established that the camera is in the air and it flies through looking downwards on the scene and it flies through that point cloud. I could also generate individual groups of points that would be useful for the 3D guy, but specifically one last thing that might be worth doing here would be to define a real-world measurement. So I can say, hey, I want to define the scale of this. I want to say this bush is essentially 3 meters away from this bush. So I can literally dial in the scale here, and you can see that the entire world of my scene is scaling based on the way I pick it. So this is just very useful for passing between different artists. Now, just because we're moving quickly here, I want to show you in just a moment a more detailed example of working with the 3D. But so for now, let's just go ahead and import the work of the 3D artist so that you can see how this would go together on the compositing end. So, like I said, they're going to build us a simple geometry. I think you could imagine that. Hills, trees, that would look a little bit like this. So let me just go ahead and bring this in. So what I'll do is I'll just take, using the FBX format, I'm actually going to take this straight in, and here's our Anaglyph model, which if I just turn my shading on here, you'll be able to see what I'm up to. So this is the kind of thing that could come back from your 3D department, right? So based on your tracking, if I were to just come in here and turn on my my stereo camera, like I did earlier, you see how I get an instant stereo result just looking at the geometry. So if I were to jump through here, you can just see how I've defined essentially a stereo environment based on this geometry. If I actually take a look at the camera settings here, one of the things that you can do is you can define a parallax plane. So this, if we look at our working view again, you can see how essentially the Autodesk way of dealing with stereoscopic is from a 3D point of view. So we're literally laying out our scene in space, if that's what you need, to generate that. And this is the essentially the screen depth, which we can observe here. We can work with, again, if I turn the icons off, you can see how I've set the tree as our convergence point. I can animate that over time as well. So the next thing to do then would be to actually combine the images now. So let's take our original image, and what we'll do what we call a wrap, which is really a projection or camera-based projection here of the original image. So what will happen here, if we just come back and look at our result, I don't want to just do essentially UV wrapping of my models, right? I want to do a camera perspective wrap or a projection mode. So then to just sort of finish this off, you'll see how if I project from the foreground here, and I actually just neutralize my materials here, now what you see is the original image, but now it's projected or wrapped around its own models. So from this point of view, you can really see how this works, right? So you can see the trees in the foreground, you can see the mountains going back and forth in time, you can see the whole shebang. One last thing that you might do in this situation with a little bit more time for refinement would be to actually use some of your masking tools to refine the edges. Those of you with a BDI would have noticed that our trees were made of spheres and not exactly the same shape as trees, but how it's not efficient to have your 3D guy make individual branches, whereas rotoscoping can really help you in this area. So you can see how, if I look in closely here, you can see how my rotoscope here is really the fine edge that defines the edge of the tree. So if I were to pull this back and forward, you can see that if I let this edge go out too far, what's happening is that that horse is being projected at the depth of the tree instead of at the depth of the ground. I can even turn off my tools here, and you can start to see how different pieces can be cut in different ways. So I'm building myself a mask here that will essentially allow me to define the exact edge of a given piece of geometry. So it's just a really neat way of doing that. A little bit of roto, a little bit of 3D geometry. This last example we wanted to show you takes a really quite complex scene that requires very much a complete scene exchange between your compositing environment and your CG environment. So let's just take a look at the plate. This shot here, as you can see, is kind of full of depth cues. What I mean by that is there's the guy in the foreground, there's a wall that goes away diagonally, there's the table and the teapot in the foreground, all of which could be nice little moments, little separations in stereoscopic 3D if we could get that kind of separation. So I do the same process that we did on the tree here. I would go in and do an analysis of this scene with my camera tracker to produce a foundation, right? So then the next step would be to hand this camera and these point clouds across to our CG artist to actually build us out a complete environment. So the process here is to really use some of the higher level functions of FBX. That's the Autodesk FBX format, including things such as our camera, the individual models, and what we call geometry cache. So animated geometries, obviously the blocks are going to be still, but the man is going to be moving. We'll take advantage of that HIK rig in Maya, which Daryl is kindly going to show us just a few minutes of.
All right, so here we are inside of Maya. Obviously, we've got the same camera track with that cloud, and that's going to assist us in placing geometry in our environment. So we'll go ahead and we'll turn on the kitchen, and you can see that I've already got a good bit of this geometry placed. I just started to kind of lay this chair out. And this is something that's kind of cool because of the masking capabilities that are inside of Flame. You don't really need to be that precise with your placement of this geometry. If you just crank through it really quickly and get the kind of broad strokes, the masks will allow you to basically go in there and have the refinement done at that level. So if we jump over to a shaded view and we start to scrub through this, you can really start to get a sense of the volume of that room and really how it feels. You can see I just animated that box on there. So the next thing that we need to do is we need to get the character going in here. And again, this is one of the things that's really nice about this, because we're just trying to get some good Z information provided to Flame so that it can start to project those original live action plates back on top of that geometry. The animation that you get for the character doesn't have to, again, be super precise. So we'll go ahead and turn on this guy. And it basically, this is just a little dude that we downloaded off of Turbo Squid. He's been set up with the Human IK rig, which gives me a very elegant set of tools for posing and positioning this character very quickly. So if I just grab this character's arm and I'm in body part mode and begin moving it around, it's just going to use an inverse kinematics chain to simply position where that character's hand goes. That's pretty straightforward. If I go into full body mode, you'll see that I have the ability to now pose this character in an extremely realistic manner. If I overextend that arm, his waist basically drops down, his legs stay fixed. So this Human IK algorithm lets you pose characters very, very fast. Now, when we're doing this kind of posing work and trying to match this character in, he's not going to, I don't have the time to sit here and really dial in the animation and make it 100%. So what I'm going to do is I'm going to take a duplicate version of that character and just move it out based on the normal. So I just puff this guy out, and then that allows me to be super loose with the animation. I just need to sort of half match it up and try to get it in the general space of where that character is moving, bake that out as an animated texture map, or I'm sorry, as a vertex cache that FBX can bring back in, and will take it over and project the original background plate on top of it.
That's right. So as Daryl was kind of inferring there, I get to do the really hard part with rotoing out the guy. And indeed, I just wanted to let you know that this can be done in a modular fashion. I'm actually pulling out some of the big iron keys of the Flame tool set here in Flare. The 3D keyer, which is a tool that allows us to get amazingly clean isolations of edges for hair. And in fact, you need to bite this off in a couple of chunks. So that's the reason that we use those multiple mats. Here's a different key, which I was able to get for the edge of his jacket, which obviously inverted would give me a good key to get the window. And then so on and so on into essentially a piece of rotoscoping that looks like this. So then essentially the fine edges is done by the keying, and the broad edges is done by the actual wireframe here. So this is just to see how that's no good there. We need to suck that in, need to roll this out, and so on. So this is just a great approach. Took about 3 hours to do this actually, and then you continue to roto out different objects. Here's the box that is in his hand, isolated. That was the much quicker job, just multiple shape trackers like we saw earlier with the hand. And then here is a little bank of pixel spread tools that we're using to effectively reduce essentially the edges on the guy. And And whilst I do think that, ultimately there might be certain things that would have to be done with paint, this is a great function where you can deal with essentially the different pieces. We even chain them together here to do essentially take all of their mats together and then suck all of that in at once so that you've got a cleaned up element that could be projected onto the rest of the back furniture. The end result here would be something that looks like this. So hopefully you can just get the idea that even with this level of complexity, let me just show you the working view here so that you can see all the pieces in place. You can see the tree up there, which was also a key. You can see the lamps. And obviously from perspective, it looks kind of funky. But from the direct point of view of the camera, you can see how this is going to work, right? Just a really cool combination of techniques that can give you a really nice, clean result for a really sort of deeply extracted scene with a lot of different layers of depth. Even the teapot here, as you can see, standing out from the table because it's an individual element. All right, well, so thanks so much for listening. What you've been looking at is the 2D to 3D stereo conversion process using Autodesk Flare in the Flame Premium family and Maya.
Thanks a lot, Will. Excellent job.